Thanks, Joel. So, like Joel said, I'm Sloan, Vice President at the Council for Affordable Health Coverage, and I get the privilege of introducing Doris Taylor. So when we were planning the flow of the conference, I really wanted to end on a high note, because I know there's lots of politics being talked about, lots of back and forths, solutions that Joel pointed out, but also lots of problems with the healthcare system. And when I think about the future of medicine, Doris Taylor comes to mind. So I met Doris last year, and she has an incredible story, but the thing that I'll leave you with, which she's gonna talk about, is she was, number one, nominated for the Time Magazine's 100 Most Influential People in the World. And then number two, she bioengineered the first beating human heart. I thought it was impossible till I saw her talk. So with that, I'm gonna let you read her amazing bio in the pamphlets, but Doris Taylor.
So thank you all who stayed to the bitter end, and hopefully we will end on a high note. I want to thank you, Sloan, for having me. I want to thank everyone. This is such an opportunity, and I'm really grateful to be here. And I want to talk about what if we did something really radical and actually tried to cure disease. Novel concept. So that's where I want to take us today, because I believe the only thing that actually is going to be the same degree of tech revolution as AI is regenerative medicine. So I want to talk about that today. What is regenerative medicine? Regenerative medicine is the idea that you can treat an underlying injury or disease rather than just the symptoms of a disease. What if we actually gave people drugs that cured them? What if we actually only had to pay for drugs for a short period of time because people got well? Novel concept, that. It's also, regenerative medicine is also personalized medicine, and for my purposes today, I'm going to talk about regenerative medicine that uses cells or genes as a tool. And there's a typo on there that wasn't there this morning. Oh well, been a long day. So regenerative, the video we just watched about global, actually the US needing to lead in artificial intelligence, I would say we're in the exact same position with regenerative medicine. Regenerative medicine is our opportunity for the next biotech revolution. And together with AI, it will not only change medicine, but it will change humanity. And if you think it's not a big deal, the total global accessible market for regenerative medicine in 2023 was already 34.56 billion. And it's expected to grow to close to 400 billion within the next 7 years. That's a big jump. Average CAGR 32%. However, China, Japan, and the EU are investing heavily in these technologies, and we in the US need to do the same. The US has to lead the world in regenerative medicine, or we risk losing ground. Why does that matter? Biotech, regenerative medicine, when you take a gene or a cell, is designed to last forever. And you talk about something that can be weaponized. If somebody wants to modify a cell or modify a gene and then give that to you, unlike a drug that normally would go away after 24 hours or 48 hours, cells, genes, and organs are designed to last for the long term. You can't take them back. And if you think regenerative medicine is not going to be bioweaponized, I have one word for you: COVID. Let's talk about the potential for a virus being mutated, intentionally or not, and then being released. So government support and policy incentives are essential if we're going to lead in this field. Okay, so again, I said regenerative medicine is personalized medicine and it uses cells and genes as a tool. Because stem cells is a loaded word, I want to tell you what I mean when I say stem cells. Stem cells are simply cells medically that we define in two ways. They're cells that can self-renew, make more of themselves, and they can differentiate or become different types of cells. And the cool thing is we have stem cells in virtually every organ and tissue of our body. The common sources are cord blood. People say, do you want to save your baby's umbilical cord blood? The irony is fat is full of stem cells, bone marrow, and muscle. So they're everywhere, and they actually are present all of our lives. And I want to put something out there that I've been saying for the last 20 years, and I want you to hear me. Aging is a failure of stem cells and a failure of our capacity for endogenous repair. And if you don't believe that, think about the fact that if you have a 2-year-old in your life, and that 2-year-old falls down and scrapes their knee, what happens? Turns red. Turns red, that's inflammation. If I fall down and scrape my knee, and by the way, I'm a little older than 2, it's still going to turn red. Still going to be inflammation. Inflammation is basically nature's cue that says, help, I've got an injury, send me cells. And you actually get cells there from your blood supply. And in the 2-year-old, what happens? They form a scab, the redness starts to go away, they heal, and they don't have a scar for the rest of their lives. For those of us who are 52, 62, whatever, if we'll still scab, we'll still, for the most part, heal, but we may very well likely have a scar. Why? Because as we age, those cells that get recruited, those reparative cells decrease in number, cell replication goes down, and the potency of the cells we still have goes down. So the whole concept of stem cell therapy and regenerative medicine is to deal with situations where either we don't have enough cells, like as we age, or in conditions where we don't have enough time, like in the case of something like a heart attack or a catastrophic injury, when you need hundreds of millions of cells and you need them within minutes. And so many of us who have been in the regenerative medicine field, and I just want to make an aside here, you can't actually talk about endogenous repair and aging as a failure of stem cells without acknowledging that there are certain things that make aging worse. Inflammation is one. We all hear about chronic inflammation these days. Acute inflammation is a good thing because that's nature's cue to get cells. If you get the cells there, you turn off that inflammation. If you don't, your body ramps up the inflammation and says, hey, I've got an injury, send me cells. And then you start recruiting pro-inflammatory cells, and you have a chronic inflammatory response. Well, what accelerates that inflammation? Stress. Stress is another word for inflammation. And if you don't believe that, I just have one set of pictures to show you. Okay? Here we are, 4 years. What a difference stress makes, right? I feel like this after some weeks I spend with certain people, but that's a different conversation. So all of us in the regenerative medicine field, our goal is to break that cycle of chronic inflammation and restore the capacity for endogenous or self-repair. And that means we want to develop therapies that will actually increase your stem cell number or increase the stem cell function and potency of the cells you have. And acknowledge that we're putting them into that stressful environment and say we need to increase their ability to survive under stress, but nobody wants to be the person who says, the good news is I cured your heart disease, the bad news is I gave you cancer. We have to make sure those stem cells aren't uncontrolled. That means we have to deal with the downside, which is uncontrolled cell proliferation. But a couple of points I want to make. One, stem cell therapy is not new. It's about 65 years old because the first time we did a bone marrow transplant in the 1960s, we were doing stem cell therapy. We just didn't know it yet. We didn't have the scientific wherewithal to know that our bone marrow was full of stem cells. So it's not a novel concept. So successful cell therapy has been going on for a long time, longer than most of us have been alive. However, successful commercial stem cell therapy didn't happen until 2010. And in April of 2010, the FDA for the first time faced the question of whether they were going to approve a stem cell therapy. And it was a stem cell therapy for advanced prostate cancer. And I actually sat on the FDA Cell and Gene Therapy Advisory Panel that heard that request. And you know what? Initially, we didn't let it go forward. Why? In part, I'm speaking for myself, no one on the agency here, but in part because we didn't know at the time if we approved a stem cell therapy, if it would be used off-label for everything else. And we'll come back to that in a few minutes. But that went forward ultimately, not in that hearing, but in one not long after that. And since then, we've actually now got, 2 years ago, we had 27 FDA-approved cell therapies that were either umbilical cord derivatives or CAR T cell therapies to treat cancer. However, as of this year, or as of the end of last year, that number rapidly had increased to about 40 stem cell therapies. So this is starting to happen more and more and more, very rapidly. But most of these stem cell therapies are either only approved for certain solid tumors, for autoimmune diseases, for cancer, or for some inherited metabolic disorders like sickle cell disease. So the truth is that we have some stem cell therapies, but only for very rare cases. The other place where stem cells can be used, interestingly, is in the operating room. If a surgeon actually is in the operating room for a different reason and believes that you will benefit from stem cell therapy, they can be used as part of the surgical procedure. Everything else you hear about is either a clinical trial or not approved by the FDA. So this is one of my favorite slides, and I just added this today. So are there given that endogenous repair is what we want to actually have happen, what if we actually looked at, less expensive alternatives for the healthcare system? Well, I put up here, Make America Healthy Again. What a novel concept. So my favorite used to be a glass of red wine. What can I say? Because people do believe resveratrol is beneficial. But we've actually done clinical studies that show, remember how I told you stress was another word for inflammation? We've done clinical studies that show all those things we've been told our whole life that reduce stress, like exercise and acupuncture and meditation, all of those things actually increase the stem cell numbers in your blood and improve your health, including your cardiovascular health. But the reality is clinical trials are the safest way for any regenerative medicine to move forward. And we have done clinical trials on some of those alternatives. But as we're talking about today, clinical trials take years, and there's a huge unmet need. Medicines are not working. Prescription drugs are not working. And so people seek out other opportunities. So I want to talk about that other opportunity, because one of the things we've heard the new head of Health and Human Services say is that he wants to see stem cell therapies approved. And nobody is pro-stem cells more than me. However, in 2016, there were actually about 570 stem cell clinics in the U.S., most of which are delivering unapproved, illegal stem cell therapies. And those numbers have continued to increase, and at the end of last year, there were over 5,000 illegal stem cell clinics. And if you're in any big city and you pull up your phone and you look for stem cell therapy near me, you're going to find it. You can go get it. The reason I'm bringing this up is not because I don't approve stem cell therapy. I've actually sent friends, family members, and colleagues to go get it when they didn't have other alternatives. But to say that we want safe stem cell and vetted stem cell therapies to move forward, not just every clinic that exists in the U.S. But regenerative medicine is not just about cells. There are a number of advanced therapies that are actually being evaluated clinically. They include gene therapy, cells for cancer, cell-based immuno-oncology, cells for other disease states, and even tissue-based therapies like new joints or new ligaments or new tendons, for example. But we've all seen that there are 40 approved cell therapies primarily for cancer. So why is regenerative medicine succeeding in cancer but not in other areas of medicine? I would say it's for two reasons. One, cancer has a face. Everyone looks around and thinks they know when somebody has cancer, and we don't always know that for other diseases. And so I'm going to take a minute and talk about the number one killer on the planet, which is heart disease, okay? Heart disease actually is the number one killer of men, women, and children globally. 32% of all people in every country on the planet die of heart disease. It's a leading cause of death. Number 2 is COVID. Number 3 is stroke, which is essentially a heart attack in the brain. It's the exact same disease, just different target. And it's a huge economic burden in the U.S. In the U.S., the cost every year is on the order of $407 billion. And 34 million people are living with heart failure in the U.S., and there's at least a $40 billion addressable market. But it's not static. It's expected to triple by 2050. The costs to the U.S. economy are going to be staggering. They're more than all cancers combined. So I have a question for you. How many of you know a woman with breast cancer? A lot of people in the room. How many of you know a woman with heart disease? A few, but not very many. Did you know that actually 5 times more women die of heart disease than breast cancer? 5 times. In fact, every 34 seconds, somebody in the world has a heart attack. During the course of today, while we've been sitting here, 634 people have had a heart attack. And the the 10% of those people die within an hour. 63 people have died while we were sitting here. But the remainder, in fact, develop a scar in their heart and go on to lose heart function continually over time, culminating in what we call heart failure, which is an inability to feed the organs in their body because their heart can't pump or relax appropriately. I've already said 5 times more women die of heart disease and breast cancer. You know what the statistic in the US is? 48% of people in the US over the age of 18 have heart disease. So let me put that in perspective. Look to your left and look to your right. If it ain't them, it's you. One of the 2 of you has heart disease. So can stem cell therapy do anything to prevent heart disease? Well, it hasn't so far. My group was the first group to actually put stem cells in the heart back in the 1990s. And since then, about 185 clinical trials have been done, and there are about 40 underway right now. But there are 0 approved therapies. And we can have a whole different conversation for 2 hours about why that is. We're 20 years out. Part of that is because of the approval process in our country and the fact that we have to design trials in a very specific way that are not current for biologic therapies. That said, there's some small improvements in heart function. People are spending less time in the hospital, and there's some improved heart failure outcomes. But one of the failures is the fact that most of the studies are conducted in people over the age of 60, using their own cells. And I just told you, cell function goes down as we age. So we're giving everyone kind of a dud drug, right? And if I draw blood from you and anyone else in the room, we're going to get 3 different samples, right? And yet, that's the drug we're giving someone if we give them their own cells. So we're basically giving every person in a trial a different drug and then trying to compare. So the noise in the system has been outrageous. And in fact, when I pushed the NIH and I pushed the multiple other groups, and I actually went back and did some analyses rather than adjusting for men versus women or by race and ethnicity, we actually found that if you start separating people, there are improvements in some groups and not in others. But I really am here today because, sometimes we can't fix it. There are tens of millions of people in the US alone living with heart failure. And in those cases, the only option, the only thing that is going to improve their outcome is a heart transplant. So sometimes we can't fix it and we need a new one. And if you're going to get a new one, you kind of want a really cool new one that works well and actually will get you where you want to go in good shape for the rest of your life, right? And the estimated data are that every baby being born in the US today, 1% will need a heart transplant in their lifetime. That's a big number. So we need to be focusing on this. And in fact, my mentor, Dr. Denton Cooley, who many people, not just me, will acknowledge as the best surgeon who ever lived, said, in our line of work, someone has to die for someone else to live. I want to change that. The truth is, donor heart transplant is imperfect. We only transplant 10 hearts a day in the US, 10 hearts a day in the US. 20% of all available organs are recovered, so even if and every day 10 are transplanted, 3,700 people are waiting. So even if we got all 100% of the organs that were needed and went from 10 a day to 50 a day, let's be really clear, only 3,200 people are waiting every day. In addition, you only make the transplant list if you're very sick, but you can't be too sick, and you can't be too old. And you've got to be able to pay for the drugs that you're going to have to take every day for the rest of your life. And let me be really explicitly clear about that. Those drugs cost anywhere from $2,500 a month to $25,000 a month, depending on which drugs you need. So today, heart transplant is an emergency surgery that has to happen within 4 hours of the donor dying, and you have to be exceedingly sick to get a heart. And then every day for the rest of your life, you take drugs that give you diabetes, high blood pressure, kidney failure, so that many people who get a heart transplant need a kidney transplant down the road. They immunosuppress you, they put you at a high risk for cancer. And I had a young woman call me and she said, you know what, I had a heart transplant at 18. She said, I was born with heart disease. She said, it's true, I no longer walk around with a medical backpack on my back because I have heart failure. But she said, instead, I now have OCD, anxiety, and depression because I am terrified that I am going to get so busy that I forget my pill one day, and then I will die. So today's solution is imperfect. And the status quo for heart transplant has not changed in 55 years. It's time to do it differently. So let's talk about building personalized, on-demand replacement hearts. If we could do that, they'd be personalized. They decrease your risk because actually you could plan your heart transplant when you had a heart attack, or if someone in your family had had a heart attack, or if you were born with congenital heart disease. We could start planning way upstream. We could actually give you a heart while you're sick, reduce your lifetime cost. Heart transplant lifetime cost $2.8 million. We could reduce that by 49% by actually giving you a heart earlier and avoiding all those drugs that you now have to take. In addition, we improve your quality of life and we cure your heart disease. Plus, because we could do that and we could plan, we could make them for almost anybody and make them available. So in 2005, I said, let's build a heart. How hard can it be? 2005, 20 years ago, I started this when I was at Duke and then at the University of Minnesota. So I said, fortunately, I'm not an engineer, and I was like, I don't know how to build a heart, but I know what I think we need to know to build a heart. And if I had been an engineer, I would have said it's never going to work. So what I did is I said we need heart cells. And the first time you actually see heart cells, and I'm going to go backwards so that you can see the video of those cells actually beating in a dish. The first time you see heart cells beating in a dish, you go, oh my God. But that's alive, and it really changed my perception of the world, you know? But heart cells are not a heart. And in fact, you need a place to put those heart cells so that they can be a heart. And I'm pretty straightforward. If you get to know me, you're going to find out just exactly how straightforward. But what I said is, well, nature has figured out a place to put heart cells. So maybe we just need a framework, and let's take a heart and let's actually get rid of everything that's inside that framework. So we use the equivalent of baby shampoo and that should scare you a little bit. And we washed all the cells out of a heart. And when we did that, what we had left, this is a time lapse of doing that, is this underlying scaffold that's called extracellular matrix. Why do we have to make it so complicated, right? I call it goo. No, it's actually, the media has dubbed it a ghost heart because it looks like a translucent heart. But then we said, let's put heart cells back in. And we did. And within a year, we had created this beating heart in the lab. Now, the cool part about that was we created this heart, took us 1 year to do it, took us 2 years to get it published in the scientific and medical media, because one reviewer said, well, if it's still beating, they really didn't wash all the cells out. And another reviewer said, that's impossible. Another reviewer said, that's not novel. I was like, how do you respond to that? So what I finally did is I called the editor of the medical journal and I said, look, we can only transplant a heart 4 hours after it's harvested from someone. If I took a heart and I held it in the lab and I put it through baby shampoo and a week later or a month later it's still beating, that's worth publishing anyway. And that's when we got our paper published. And it was a big deal. But let me be clear, in 2008, politics notwithstanding, it was only a rat heart, right? And so I said, okay, that was great, but let's build a human heart. How hard can it be? Well, let me tell you what the human heart does very briefly. First of all, your heart's the size of your fist, okay? So the larger you are, the larger your heart is. When we're born, our heart's about 20 grams, anywhere from 20 up to, and as we age and as we get larger, can be up to 350 in a healthy person, 450 with heart failure. And so what we found is that for every gram of heart we want to build, we need 1 billion cells. So to grow a human heart the size of 350 grams an adult, I need 350 billion cells. And if you want to think about what that is, line those cells up. First of all, we can't even see a cell with our naked eye, right? Line those cells up next to each other, and they will stretch out for 41,000 miles. That's how many cells it takes. We also have to build a heart that can beat 60 to 80 beats a minute. Every minute. Not most minutes, not some minutes, every minute. It has to have enough energy to power a Mack truck to the moon and back. That's a lot of energy. I actually want to talk to our Congress folks about, maybe they ought to be harnessing some of our energy to be energy dominant in the world. What can I say? Have a great idea for a battery. Has to be able to now pump 1.5 million barrels of blood over the course of your lifetime. That's a lot. And just you see in the bottom here, one of our larger hearts that we stripped of its cells, and it has to actually contain 60,000 miles of blood vessels. So we have to actually build 60,000 miles of blood vessels in these hearts to keep them alive. Okay, so fast forward 12 years of my life, and what we were able to do is go from a small heart to a human heart that was actually about 3 times the size. However, at that rate, it was going to take me 42 years to build a heart that was big enough for even a young woman. And I was like, I don't want to do this for the next 42 years. I want to get it done in my lifetime. So, March 12, 2020, I resigned from my job. March 13th, 2020, the world shut down. So I found myself without a job. I found myself saying, okay, if not now, when? So I spent the next year talking to folks, and then in 2020 into 21, I got smarter and I started a company. And I found partners from the Department of Defense and who were automation experts throughout the industry. And by doing that, what I was able to do was build a closed, automated heart manufacturing line where instead of having to do everything by hand and our Rube Goldberg, heart apparatus, we were able to create automated computer-driven systems, and I actually had to teach a robot how to inject cells into a heart. That was kind of fun in a weird sort of way, and I taught it to fist bump me at the end. That was the best part. By doing that, we were able to scale up to the first actual functional beating human heart in less than a year. So I say, imagine a future where you go to the lab, somebody draws your blood, they grow billions of stem cells, they take a scaffold off the shelf, and they put your stem cells in it, and they create a heart that matches your body. Well, it's not a cartoon anymore. We've done it. We haven't put them in people yet. Let me be clear about that. We're doing animal studies. But we've built over 50 of these, and we've built we've built thousands of scaffolds. We have all the components in place. I will say the broken supply chain in the US has hurt us, but we can have a whole longer conversation about that. So I would say building a heart and building heart is not just a potential medical breakthrough, it's a hope for innovation and economic growth. And why? Because every step in this process is actually the opportunity for an industry. When a patient goes to get their blood drawn, that's the opportunity for us to be biobanking stem cells from individuals. When we make these scaffolds, we can build cardiac valves for valve replacement. We can build cardiac patches to prevent the progression of heart failure. We can pull out vessels for bypass surgery. All these products. Cells. The cells that we actually use and grow up and teach how to become heart cells can be used to actually test new drugs going forward so that you could actually get a personalized drug that matches your body and is going to be effective before you have to take it. Bioreactors, a place where we actually keep these hearts and keep them sterile. Those have to be built. That's manufacturing. And then I picked heart because it's the hardest. But in my group, beginning in 2008, we were doing kidney, liver, lung, pancreas. This is about changing people's lives, okay? And so if you're going to do that, you need a team, you need a plan, and you need funding. And I'm going to skip a couple slides to say, because I've already talked about those, I'll just show you a cool picture of our cardiac patch, actually transplanted on the surface of a heart and actually prevented the progression to heart failure. We've got a plan for all of this. This kind of sums it up. We've moved from science, we've spent $70 million of academic funding to get to the point that we spun off a company. We've moved to manufacturing, but we will not make it all the way home if the regulatory processes are not in place and if reimbursement strategies are not available. So I'm really particularly interested in watching how CAR T therapies and value-based reimbursement are emerging, because we actually will decrease the cost of heart transplant by half. That is a value-based argument, in my opinion. And so I'll leave you with the question is when and who. Are we going to do it here in the U.S.? Are we going to do it now? It's not a matter of if, it will happen. The question is just when. Last two slides. I would say regenerative medicine is more than a medical breakthrough. Investing in startups, not necessarily mine, but other biotech startups, job creation, biotech exports, reduced long-term healthcare costs. And we need FDA reforms and reimbursement pathways for that to happen. So I would say, in a call to action, that we actually have to support moving safe regenerative medicine products forward in an accelerated manner. This is not the time to be decreasing NSF and NIH and other funding. We need to actually, we all need to be arguing for indirect costs with our legislators. We need to build insurance reimbursement models, and we need public-private partnerships to drive this forward. Because every day we don't do this, people die. Now, one of my mentors when I was at Duke, when we were debating heart failure drugs, said, if people are going to talk about money and what it costs, the cheapest option is death. That's not where I believe we as a country deserve to be or need to be. We have the opportunity to change medicine forever, and I just want to say thank you for my chance to tell you about what I think is the future of medicine.